Okay, GCF can be a difficult idea, so I'm going to take some time to really just explain what GCF is, and then I'm going to show you what might be a new way of finding the GCF. So let's get started. The GCF is the greatest common factor, If you are like I was when I was learning this, that made no sense to me. So what I learned to do is break down every word to see if I could figure out what in the world those math people were talking about. So greatest in regular life means biggest. So that is pretty clear. A factor is a math word that means something you multiply to get a certain answer. So an example of factors are, what can you multiply to get 12? Well, 12 have factors of 3 and 4 because 3 times 4 is 12. 12 has factors of 6 and 2. So 6 and 2 are factors of 12 because 6 times 2 is 12. You could also get 12 with 1 times 12. So 1 and 12 are also factors of 12. So factor means a number you use to get a larger number, and it is related to multiplication. Now we have this word common, and it is a regular English word, not a crazy math word, and it just means what is the same for every number we're considering. So let's look at an idea without numbers first. We're going to look at people, and we're actually looking at the colors they're wearing. And what we are looking at is what colors are common to all three people. So I guess we could use some names: Sally, Joe, and Lillian. I have no idea. Those are just what popped into my head. I know my husband's name is Joe, so that's probably where that one came from. Okay, so what colors does Sally have? She's got like a green necklace. She's got an orange dress going on. And she's wearing a red belt and red shoes, so she's got red. Joe here, he's got the red tie, blue suit, green briefcase. So he's got red, blue, and green. I guess his shoes are white. It looks like I didn't color those in. So we'll say he's got white also. And Lillian. Lillian has gold earrings, or we'll call them yellow for this, because we're talking about colors, yellow and gold. Okay. Some blue on her dress. She's got a green belt. She's got little green shoelaces also. And down here she's got orange on those shoes. Okay, so we've taken a look at all those things. So what colors do all three have in common? And we want the most amount of colors that they have in common. That's the greatest part, the most amount that they have in common. So Sally has green. Does Joe have green? Yes. Does Lillian also have green? Yes. So part of their greatest common colors, green is part of that group. They all have green in common. Sally has orange. Lillian has orange, but Joe does not have orange. So though two of them have orange, orange is not common to all three people. See, I wrote down green, so I'm going to cross it out because I get confused easily. I want to keep everything simplified. So I considered the orange. Though Sally has it and Lillian has it, Joe does not have it, so it cannot go under my list of greatest common colors. All right, next, Sally has red. Joe has red, and Lillian has red. So red is in my list of common colors. I'm going to cross them out. Oh, I never wrote red down here, but we see her dress has got red all over it. Okay, cross that out. So Sally's list is done. If I have used everything up from one thing, then I know my common list is also done. But let's just look at it to prove it to ourselves. So Joe also has blue. Lillian has blue, so it's looking good. But again, Sally has no blue. So though blue exists, it's not common to all three people. Lillian's rocking the yellow, but nobody else is. And Joe's wearing those Pat Boone white shoes, but nobody else has white clothing on. So the greatest common colors, the most colors they have in common, there's two of them, green and red. Now let's look at this in terms of numbers. To do this, we need to know about prime factorization, because numbers are built out of prime numbers. So to really see what numbers we have in any given set, we need to break them down into their building blocks. It's like the Legos of all the other numbers. The first Lego building block is 2, and it counts up from there. This is a list of primes up to just below 1,000. Prime numbers go on forever, so it does no good to try to memorize all of them. It wouldn't hurt for you to memorize, and if you do this long enough, you're going to know the first few off the top of your head. But I would suggest you keep a copy of most of the lower prime numbers handy, just to make your life easier. Let's find the GCF of 30, 45, and 75. I am going to teach you what is called the ladder method for finding GCF. And the reason is, if you just follow the process, your brain doesn't have to do any heavy lifting. So I start by writing an upside down divide sign, or an L here for ladder. And I go to my first prime number. And I ask myself, can 2 divide into each one of those? Not just one of them, but all of them. And for that, if you don't know off the top of your head, simply use your calculator to figure it out. So I would go, well, I can't remember if 30 can be divided by 2 with no remainder, so I'll plug it in. 30 divide 2, and yes, that one works. But don't write the 2 down yet. Try 45. Can 45 be divided by 2? No, there's a decimal answer. We don't want that. We want clean whole numbers. So 2 is not a common number to all three of our numbers here. Then I move on to the next prime number, the number 3. Same thing. If your brain's not working, use a calculator for this. It could be tedious to do these all by hand. So 30 divided by 3, do I get a nice clean whole number answer? Yes. How about 45 divided by 3? I again get a nice whole number answer. How about 75 divided by 3? And all three numbers then have the number 3, the prime number 3 in common. So now I'm going to write the 3 out here and write the answers I just got when I divided them. So 30 divided by 3 is 10. 45 divided by 3 was 15. And 75 divided by 3, I believe, yes, was 25. Okay, that was nice. Let's do it again. Draw another L. We're going to call that our upside down divide symbol. We are going to keep using 3 until it quits working. So can you divide 10 by 3 and get a whole number answer? 10 divide 3. Definitely not. So let's move on. Our next prime number is 5. Well, off the top of my head, I know 5 will go into 10. With our 2. Can 5 go into 15? 15 divide 5. Yes, it does. Can 5 go into 25? 25 divide 5. Yes, it does. So I found another common prime. 5 goes into 10 2 times. 5 goes into 15 3 times. 5 goes into 25 5 times. Now let's pause for a second. Take a look at the list up here on the left side of my work. These are both prime numbers. I know I pulled them off the chart. Look at these down here. 2 is a prime number, 3 is a prime number, and 5 is a prime number. So what this is telling me is that I have broken these down into their primes, and these multiplied together will give me the greatest factor that is common to all 3 of those. My greatest common factor is what I get when I multiply 3 by 5. That is 15. Never fear, we're going to do it again.